Why Albert Einstein was amazed by the Buddha's discoveries. Science and Buddhism have fundamentally different approaches to understanding reality. In the realm of science, knowledge and logic play a pivotal role. Science gathers understanding about the real world and condenses it into verifiable laws. By dividing, classifying, analyzing, comparing, and measuring, scientists interpret these laws through the abstract language of mathematics. Of course, intuition also has its place in science, but it only yields results when systematized within the rigorous structure of mathematics and validated by observation and analysis. In contrast, intuition, or inner experience, plays the primary role in the Buddhist approach to reality. While science looks outward, Buddhism looks inward, using contemplation as a means of approach. Science is concerned with the objective world, whereas Buddhism focuses on the self. Instead of breaking reality down into distinct components, as in the reductionist method of science, Buddhism approaches things holistically to understand them as an undivided whole. Buddhism does not rely on measuring instruments or sophisticated observational tools, which are the backbone of experimental science. It is more qualitative than quantitative. However, the primary difference between the pursuit of knowledge in science and Buddhism lies in their ultimate goals. The aim of science is to understand the phenomenal world, focusing on knowledge about the physical universe, considered objective and quantifiable, to achieve control over the natural world. In contrast, in Buddhism, knowledge is primarily acquired for therapeutic purposes. The goal of Buddhism is not to understand the physical universe for its own sake, but to free individuals from the suffering caused by excessive attachment to the apparent reality of the external world. Empirical investigation is not the main objective of Buddhism. Instead, Buddhism seeks to understand the true nature of all phenomena, to dispel ignorance and open the path to enlightenment and liberation. Rather than using telescopes, accelerators, or microscopes, Buddhism uses the mind as the instrument for investigating the universe, emphasizing the understanding of the nature of the mind through direct meditative experience. Over centuries, Buddhism has developed profound and rigorous methods concerning the understanding of spiritual states and the ultimate nature of the mind. The mind stands behind every life experience, shaping how we perceive the world. A small change in consciousness, in how we deal with mental states and perceive people and things, can completely transform our world. Instead of focusing on the third-person perspective, the domain of the objective phenomenal world as in classical science, Buddhism also emphasizes the first-person perspective. With such fundamental differences in methods and goals, is there a common ground for dialogue between science and Buddhism? What does Buddhism have to say about the nature of phenomena when this is primarily the concern of science? The definite answer is yes. One of the main tasks of Buddhist philosophy is to investigate the nature of reality. While science is not the main concern of Buddhism, it has addressed similar questions to those posed by contemporary science. Can indivisible particles be the fundamental building blocks of the phenomenal world? Do they truly exist, or are they merely concepts to help us understand reality? Are physical laws immutable, existing in themselves like Plato's ideal forms? Is there a concrete reality behind appearances? What is the original source of the phenomenal world, and does the world around us, which we consider real, truly exist? What is the relationship between motion and stillness, between subject and object? What is the nature of space and time? For over 2,500 years, Buddhist philosophers have continually explored and pondered these questions. Buddhist scriptures are rich with treatises on knowledge and explanations of the various levels of the phenomenal world. including texts on psychology that explore different domains of consciousness and the ultimate nature of the mind. While the methods of investigation used by Buddhism and science to explore the phenomenal world may initially appear very different upon closer examination, we find that both Buddhism and science rely on empirical methods to explore reality. The analytical method commonly used in Buddhism, known as conceptual analysis, is widely used in science as well. These are thought experiments conducted in the mind, leading to conclusions that are difficult to refute, even though the experiments are not physically conducted. This technique is often employed by leading scientists, such as Einstein. For instance, when examining the nature of space and time, a physicist might imagine riding on a beam of light. Similarly, when contemplating gravity, they might feel as if they are within the effects of acceleration. In the same way, Buddhist scholars use conceptual analysis to dissect and understand reality. Buddhism, like science, encourages a spirit of skepticism in the development of belief. The Buddha encouraged not to blindly accept his teachings without personal contemplation. He taught, "Just as a wise person tests gold by burning, cutting, and rubbing it, so should you accept my words only after thorough examination and not out of respect for me." If we consider science to mean a systematic, rigorous, and verifiable body of knowledge, or a series of laws and processes related to the recognition and formulation of a problem, the formulation based on hypotheses and data gathered through observation and experimentation to test these hypotheses, Webster's Dictionary, then Buddhism can be described as a science of introspection or a science of the mind. However, here, the realm of investigation is not merely the objective physical world that we can study, measure, and calculate in a physical sense, a world that can only be described through the third-person perspective of quantitative methods, but rather a world that expands to encompass the entire range of human subjective experience, including the realm of consciousness that can only be understood through first-person introspection. In the following sections, we will attempt to compare views on reality as presented through the lenses of both science and Buddhism, and to build bridges between the science of the physical world and the science of the mind. Our goal is not to mystify science or to defend Buddhist foundations against contemporary scientific discoveries. Science performs its function admirably, independently achieving its set goals without needing philosophical support from Buddhism or any religion. When religion believes it can bring truth to science, problems arise, as exemplified by the tragedy of the Church condemning Galileo in 1633. Buddhism is the science of awakening, so whether the earth revolves around the sun or vice versa, it does not affect its philosophical foundations. Buddhism has existed on this planet for 2,500 years, while modern science only began in the 16th century. However, since both strive to find the truth and use precise, rigorous, and logical standards to achieve this goal, their corresponding worldviews do not result in irreconcilable differences but rather can complement each other harmoniously. Physicist Werner Heisenberg expressed this perspective convincingly. "I see the desire to overcome opposites, where a synthesis includes both rational knowledge and mystical experience of unity, as the mythos, whether stated or not, of our time." Chapter 1. Impermanence amidst reality. Buddhism distinguishes between two types of impermanence, gross and subtle. The gross encompasses all the obvious changes in both people and things that we witness in daily life, the changing of seasons, the erosion of mountains and rivers, the transformation from youth to old age, and the constantly shifting emotions within us. The subtle form of impermanence is more specific. In every moment, anything that appears to exist is changing. The universe is not composed of discrete, solid entities, but rather resembles a vast stream of events and dynamic flows where everything is interconnected and continuously influences one another. The concept of constant and ubiquitous change in Buddhism corresponds with the significant theme of evolution in all fields of 20th century science. Now, let's consider contemporary cosmology. The notion of immutable celestial spheres by Aristotle and the static universe of Newton have become outdated. Everything is changing and moving. Everything is impermanent, from the tiniest subatomic particles to the entire universe, including galaxies, stars, planets, and humanity. The universe is not static, but is continuously expanding due to the initial impulse received from the Big Bang. This dynamic universe is described by the equations of general relativity. With the Big Bang theory, the universe is no longer seen as something eternal and unchanging. It has a beginning, a past, a present, and a future. It has a history. According to recent observations, it will continue to expand indefinitely, becoming colder and eventually dying in a frozen state. Besides this expansion, all structures in the universe, asteroids, comets, planets, stars, galaxies, and galaxy clusters, are constantly moving and participating in a vast cosmic dance. They spin on their axes, orbit around other celestial bodies, cluster together, or drift apart. They also have lifespans, being born, growing, and eventually dying. Stars have lifespans that last millions or billions of years. Change and evolution also permeate other fields of science. In geology, the continents, which we once thought were fixed to the Earth's crust, are now known to move several centimeters each year, causing volcanoes and earthquakes at the boundaries of tectonic plates. The Earth's surface is always changing and self-repairing. In biology, the concept of evolution was introduced by naturalist Charles Darwin in 1859. Humans are no longer seen as divine beings, descendants of Adam and Eve created by God, but as products of a long evolutionary chain shaped by natural selection. Tracing back through time, human ancestors were once primates, reptiles, fish, invertebrates, and primitive single-celled organisms. The law of impermanence is not only present in the macroscopic world, but also at the atomic and subatomic levels. Particles are known to be capable of altering their nature. Quarks can change their flavor or type. Protons can transform into neutrons while emitting positrons and neutrinos. Matter and antimatter can annihilate each other to become pure energy. The kinetic energy of one particle can transform into another particle and vice versa, demonstrating that the qualities of one object can turn into another object. The electrons in the objects around us are never stationary. At this very moment, billions of fleeting neutrinos pass through our bodies every second. Due to the quantum uncertainty of energy, the space around us is filled with an unimaginable number of virtual particles, existing fleetingly like phantoms. They continuously appear and disappear. This is the most perfect image of impermanence because they have an extremely short lifespan. There is no doubt the subtle impermanence of Buddhism is omnipresent, just as contemporary science describes reality. Chapter 2. Dependent Origination and the Indivisibility of Phenomena. One. The Middle Way. The concept of dependent origination is the central view of Buddhism regarding the nature of reality. It states, nothing exists independently or by itself. An object can only be defined through its relationships with other objects and exists only in relation to them. In other words, this arises because that arises. Dependent origination is essential for the emergence of phenomena. Everyday experiences lead us to believe that everything possesses something real, objectively independent, appearing as if it exists by itself with its own inherent identity. However, Buddhism views such perception of the phenomenal world as merely a creation of the mind. They call the perception of a separate phenomenon created by isolated causes and conditions conventional truth or illusion. Instead, Buddhism presents the idea of mutual causality. An event can only occur because it relies on other factors. Since everything is part of the whole, nothing can occur independently. Anything in this world can only arise because it is interconnected, dependent, and thus mutually arising and ceaselessly operating within a continuum of transformation. An entity existing independently of all others as an immutable, independent reality could not affect anything or even itself. Buddhism thus views the world as a vast stream comprising interconnected events, influencing one another. Meanwhile, the way we perceive this stream condenses into aspects of the indivisible universe, creating the illusion of entirely separate, independent entities distinct from ourselves. Phenomena are thus simple events occurring in specific conditions. By presenting this view, Buddhism does not dismiss conventional truth, the perceptions of ordinary people or the discoveries made by scientists with their instruments, nor does it reject the law of causality, physical laws, or mathematics. It merely states that if we delve deeply enough, we will find a difference between how we perceive the phenomenal world and what it truly is. The subtlest aspect of dependent origination relates to the relationship between the name and the form of an object. The form of an object includes its position, dimensions, shape, color, or any observable characteristics. Together they constitute the name of the object, a mental construct assigned to a particular reality of the object. In daily life, when we see an object, we are not impressed by its mere existence, but by the assigned name of the object. Because we experience it, Buddhism does not claim that it does not exist. However, it does not assert that it has an inherent reality. Buddhism posits that the object exists, thus avoiding the nihilistic misconception often attributed to Buddhism by the West. But this existence is purely dependent origination. This is what the Buddha called the middle way. A phenomenon does not have an independent existence, but neither is it entirely non-existent. It can function and operate correctly according to the law of causality. Two, non-locality in the quantum world. An idea similar to Buddhist dependent origination is the concept of indivisibility or non-locality in quantum mechanics, discovered through a famous thought experiment proposed by Einstein, Podolsky, and Rosen, EPR, in 1935. This experiment aimed to prove that the probabilistic interpretation of quantum mechanics was flawed and thus incomplete. The experiment can be simply described as follows. Imagine a particle spontaneously decaying into two photons, A and B. The law of symmetry dictates that they will travel in opposite directions. If A moves west, we will find B moving east. Everything seems normal and perfect. However, this overlooks the strange nature of the quantum world. Like Janus, light has two different faces. It can be both a wave and a particle. Before being detected by a detector, quantum theory tells us that A appears as a wave. This wave is not localized. There is no probability indicating that A can be found in any specific direction. Only when caught does A know it is moving west. But if A didn't know which direction it was going before being detected, how could B predict what A was doing to adjust its behavior accordingly and be detected simultaneously in the opposite direction of A? This is unlikely unless A communicates to B instantaneously about its direction. This implies a light signal being transmitted at an infinite speed, contradicting the law of general relativity. Since there is no God sending remote signals or spooky action at a distance, Einstein concluded that quantum mechanics did not provide a complete description of reality, asserting that A must know its direction and inform B before separating. He believed each particle contained hidden variables that quantum mechanics failed to capture, making it incomplete. For nearly 30 years, the EPR experiment remained a thought experiment because physicists did not know how to perform it. It wasn't until 1964 that physicist John Bell found a way to bring the EPR's core idea from abstract research into a testable project in the laboratory. He proposed a mathematical theorem, now known as Bell's inequality, which could be experimentally tested if particles indeed contained hidden variables. In the early 1980s, advancements in technology finally enabled physicist Alain Aspect and his team in Paris to conduct a series of experiments on entangled photon pairs, photons that interact with each other. They discovered that Bell's inequality was consistently violated, proving that there were no hidden variables, and thus quantum mechanics was correct and Einstein was wrong. In Aspect's experiments, photons A and B were kept 12 meters apart, and it was found that B always knew immediately what A was doing and reacted accordingly. Physicists ensured no light signal could be exchanged between A and B by using atomic clocks attached to the detectors to measure the arrival time of each photon with extreme precision. The difference between the arrival times of the two photons was less than 10 billionths of a second, in practice, 0, as current atomic clocks measure up to 10 circumflex 10 seconds. In that time frame, light would only travel 3 centimeters, shorter than the 12 meters separating A and B. Furthermore, the same results were obtained even when the distance between the entangled photons increased. In a recent experiment conducted by physicist Nicolas Guizin and his colleagues in Geneva in 1998, the photons were separated by 10 kilometers, yet their behavior remained perfectly correlated. This paradox only arises if, as Einstein thought, we believe reality is divided and localized within each photon. The problem vanishes when we acknowledge that A and B, once interacting, become part of an indivisible reality, regardless of their distance apart, even if one particle is at each end of the universe. A doesn't need to send signals to B because they share the same reality. Quantum mechanics thus eliminates all ideas of locality, offering a holistic view of space. For these entangled photons, the concept of here and there becomes meaningless because here is also there. This is what physicists call the indivisibility or non-locality of space. This concept parallels the idea of dependent origination in the phenomenal world in Buddhism. Three, Foucault's pendulum experiment and dependent origination in the macroscopic world. Another fascinating and famous physical experiment demonstrates that the concept of dependent origination is not limited to the world of particles, but extends to the entire universe. This is the pendulum experiment conducted by physicist Léon Foucault in 1851 at the Pantheon in Paris to explain the Earth's rotation. Most of us are familiar with the characteristics of a pendulum. Over time, the direction of the pendulum's swing changes. If we start it swinging north-south in just a few hours, it will swing east-west. If this pendulum were placed at the North or South Pole, it would complete a full rotation in 24 hours. In Paris, due to the influence of latitude, Foucault's pendulum only completes a portion of the rotation in a day. Foucault realized that, in fact, the pendulum was swinging in the same direction. It was the Earth that was rotating. However, there remains a puzzling question that has not been clearly understood to this day. The pendulum is fixed in space, but relative to what? We know that the pendulum is attached to a building, and the building is attached to the Earth. The Earth carries us as it moves at a speed of 30 kilometers per s around the Sun, and the Sun itself is moving through space at a speed of 230 kilometers per s along its orbit around the center of the Milky Way, which in turn is moving towards the Andromeda Galaxy at approximately 90 kilometers per s. The local group of galaxies, in which the Milky Way and Andromeda are the most majestic clusters, is also moving at a speed of 600 kilometers per s under the gravitational pull of the Virgo cluster and the Hydra Centaurus supercluster. Yet, the latter is also moving towards the Great Attractor, a cluster equivalent to tens of thousands of galaxies. So, which of these structures controls Foucault's pendulum? To determine which celestial body controls the pendulum, we simply direct the pendulum towards that celestial body. If the celestial body moves in the sky, but always remains in the direction indicated by the pendulum, we can conclude that this body is the primary influence on the pendulum's motion. Now, let's direct the pendulum towards the Sun. After a month, this star will deviate 15 degrees from the pendulum's direction. Next, we direct the pendulum towards the nearest star, Proxima Centauri, approximately 4 light-years away. This star remains in the pendulum's direction longer but still deviates after a few years. The Andromeda Galaxy, 2.3 million light-years away, also deviates but at a slower rate. The longer the distance to the celestial body, the longer it stays in the pendulum's direction, and the smaller the deviation becomes. Finally, only the most distant galaxies located at the edge of the observable universe, billions of light-years away, do not deviate from the pendulum's direction. The conclusion we draw from this experiment is remarkable. The operation of Foucault's pendulum is not influenced by our solar system, but by the most distant galaxies, or more precisely, by the entire universe. This indicates that nearly all observable matter is found in these distant galaxies, not in the nearby stars. Thus, whatever happens here on Earth is determined by the entire vast universe. What appears on this small planet depends on the entire structure of the universe. Why does the pendulum behave this way? The truth is, we do not know. Physicist Ernst Mach suggested it could be explained by a type of matter present everywhere, exerting influence. According to him, the mass of an object, its inertia or resistance to motion, comes from the influence of the entire universe through a mysterious interaction different from gravity, which he could not precisely describe. Since then, no one has delved further into this field. Just as the EPR experiment forced us to accept that interactions in the microscopic world differ from those described by known physics, Foucault's pendulum behaves similarly in the macroscopic world. These interactions do not rely on force or energy exchange and are connected to the entire universe. Once again, we arrive at a conclusion closely related to the Buddhist concept of dependent origination. Each part contains the whole, and each part depends on all other parts. 4. Emptiness, or the absence of intrinsic reality. The concept of dependent origination leads us directly to a third important idea in Buddhism, the other two being impermanence and dependent origination, that of emptiness or shunyata. Once everything is seen as dependently arisen, Nothing can be considered as having an independent existence or intrinsic reality. The notion that qualities exist independently and inherently must be discarded. When Buddhism asserts that emptiness is the ultimate nature of all phenomena, it means that everything we perceive around us, the phenomenal world, lacks independent or permanent existence. Emptiness here should not be understood as nothingness, void, or absence of the phenomenal world, as some early Western interpreters suggested, but rather as the absence of inherent existence. Buddhism does not endorse any form of nihilism. Emptiness does not imply non-existence. If one cannot speak of true existence, one cannot speak of non-existence either. Thus, for Buddhism, understanding the illusory nature of phenomena is an essential part of the spiritual journey. Emptiness, therefore, is not just the ultimate nature of the phenomenal world, but also contains the potential for the manifestation of the diverse world we experience. The Buddhist sage Nagarjuna of the 2nd century stated, "If something is empty, it does not mean that it is non-existent." Or as the famous phrase in the Heart Sutra goes, "Form is emptiness. Emptiness is form." If reality were unchanging and immutable, all its qualities would be too, leaving no room for any transformation. Thus, the phenomenal world would be unable to manifest. However, because things do not possess an intrinsic reality, they can manifest in myriad ways. Regarding the absence of intrinsic reality, quantum physics has made similar notable statements. According to Bohr and Heisenberg, ardent proponents of what is known as the Copenhagen interpretation of quantum mechanics, we can no longer regard atoms and electrons as entities with definite specific attributes such as speed, position, neatly outlined in clear orbits. Instead, we must see them as part of a world made up of potentials rather than objects or events. Light and matter can be seen as lacking intrinsic reality because they exhibit wave-particle duality, appearing as waves or particles depending on the measuring device. The phenomenon we call a photon will be a wave when all measurement devices are turned off and not observed. But as soon as we activate the device for measurement, it appears as a particle. The particle and wave aspects are inseparable. Instead, they complement each other. This is what Bohr called the principle of complementarity. Thus, the true nature of light and matter depends on their relational context. They are not standalone entities, but change depending on the interaction between observer and observed. Talking about the intrinsic reality of a particle, or the reality it possesses when not observed, is meaningless because we can never grasp it. Hence, according to Bohr, the concept of the atom is merely a convenient image that helps physicists synthesize various observations of the particle world into a coherent, logical system. He emphasized the inextricability of experimental results and measurements. In describing the natural world, our goal is not to uncover the true nature of phenomena, but merely to follow the relationship between various aspects of the experiment as far as we can. Schrödinger also warned against a purely materialistic view of atoms and their components. It is best not to view a particle as an immutable entity, but rather as an instantaneous event. Sometimes these instantaneous events are linked together and create the illusion of immutable entities. Thus, quantum mechanics has fundamentally revised our concept of an object, making it dependent on measurement, or in other words, on an event. Just as in Buddhism, phenomena do not inherently exist, only their relationships do.